Hello everyone, you are welcome to Organotope Chem Clinic, where chemistry becomes crystal clear. In this live class, we are going to be considering the chemistry practical revision, and our focus for this first class is going to be on the qualitative analysis. Previously, I dropped a video on quantitative analysis. I want to believe everyone has actually watched this video. If you've watched my video on quantitative analysis, type in the chat quantitative mastered, quantitative analysis mastered. If you've watched my video on quantitative analysis, the question number 1 for your coming exam, type quantitative mastered. Okay? The normal laboratory format for recording in qualitative analysis involve the tests, observation, and inference. Okay, that is the normal laboratory format for your recording on qualitative analysis. Okay, now in this qualitative analysis, we are going to be focusing on the organic analysis as well as the inorganic analysis. In the organic analysis, we're given mixture of organic compounds, which was labeled sample C. Okay, so we've been able to label the mixture of organic compound as sample C. Normally, you are not expected to know the components or the constituents of this mixture, but we all know, and I want to believe that many of you've actually run the practical exercise in your various schools before now. So I'm going to review the components of the mixture to you. So the first mixture, which is the sample C, comprises of, we have the ethanol as well as what? The ethanoic acid. Ethanoic acid. Okay, so these are the two constituents that make up the sample C. Now, in ethanol, the functional group in this compound is what? The hydroxyl group. We have the OH. That implies that we'll be testing for the presence of the hydroxyl group. And in the carboxylic acid, the ethanoic acid, the functional group right there is what? The COOH. Is that okay? So in the first analysis, we are going to be confirming the presence of the hydroxyl group as well as the carboxylic functionality in the mixture. Okay, so if you're with us, you can type sample C, ethanol and ethanoic acid. Sample C equals ethanol and ethanoic acid. Drop that in the chat while we proceed. Type sample C, ethanol plus ethanoic acid. The number of participants is still very low. Yes, Femi, that's right. Sample C, ethanol and ethanoic acid. That shows you can hear me. So that is actually for the organic analysis, okay? The second one is inorganic analysis. That means we have mixture of inorganic compound in sample D. So it has been labeled sample D. So we have sample D equals mixture of two inorganic compounds. So we have the copper sulfates, we have copper sulfates as well as sodium chloride. So these are the constituents of the sample D, while the constituents of sample C are the organic components, which are ethanol and ethanoic acid. Now, in these two components that make up the sample D, we are going to be testing for the cation right here, which is the copper-2 ion, and also we are going to be testing for the chloride in the sodium chloride. Is that okay? So we've been able to extract the facts from the reagent provided. So the reagent provided for this coming exam can only test for Cu2 plus as well as the Cl minus. So what are the ions that we are testing for? I have Cu2 plus. We are testing for copper-2 plus as well as what? The chloride ion. Okay, Cl minus. So these are the two ions that we are testing for in sample D, and these are the two functional groups that we need to test for in sample C. Make sense? If you're with me, type make sense. If you're with me, type make sense. Sample D equals copper-2 sulfates and sodium chloride. Type sample D equals CuSO4 plus sodium chloride. Make sense? Tell me you're following. We need active participants here. Elisha, you're following. That's right. I'm done. You're welcome on board. Makes sense. All right, since we've been able to identify the constituents that we are testing for in sample C, as well as the constituent that we are testing for in sample D. That means we can actually proceed with the analysis. Now, right here, I have my source. Here is sample C. Okay, I believe everybody can see it. This is sample C. In the container right here, we have the ethanol and ethanoic acid. This is sample C. And in the Petri dish right here, we have the copper-2 sulfates and sodium chloride. Okay, this is sample D. So it will be served in a Petri dish, while your sample C will be served in a separate container. Okay, now we are going to identify the reagents that has been provided for this qualitative analysis. So the reagents are, we have the sodium hydroxide right here. We have aqueous ammonia right here. We have potassium cyanoferrate 2 right here. We have silver nitrates. In the measuring cylinder, I have H2O, which is water. We have the HCl, that's hydrochloric acid. We have H2SO4. We have the ethanoic acid, okay? The ethanoic acid has been provided as well. 6 molar, we're told to provide 6 molar ethanoic acid. Right here we have lime water, okay? You know what that is used for. Then we have the sodium hydrogen carbonates. We have pure ethanol. And right here we have our ethanoic acid. Okay, we've actually made the mixture of ethanol and ethanoic acid. So that is what you have in the sample C. Okay. Reagent confirmed. Type reagent confirmed if you can hear me. Reagents confirmed. Type reagent confirmed if you can hear me. Reagent confirmed. Masuro, you're welcome. Type reagent confirmed if you can hear me. Femi, Elisha, that's right. So you'll be guided by the qualitative analysis question right here. So I would like you to pick up your pen because I'm not going to write the question on the board. I'm going to dictate the question. So we are going to follow the questions step by step. Make sure you like this video so that it can actually reach out to wider audience. Like this class so that it can reach out to wider audience. Continue to like, once you're online, continue to like this video so that it can reach out to wider audience. Reagent confirmed. All right. We are starting this qualitative analysis with sample C, okay, which is the mixture of ethanol and ethanoic acid. We've identified that in this container. Now, from the structured question right here, I need you to write from the structured question right here. C is a mixture of two organic compounds. C is a mixture of two organic compounds. Carry out the following tests on sample C. Carry out the following test on sample C. Record your tests, observation, and inference. Again, C is a mixture of two organic compounds. That's ethanol and ethanoic acid. Carry out the following test on sample C. Record your tests. That's the first column, observation, inference. Okay? So test 1. Are we good to go? Test 1. Are we good to go? Type good to go. Good to go. Are we good to go? I'll be dictating the question now for each test. Good to go. Yes, Orogun, Femi, good to go. Elisha, good to go. All right, we are good to go. Test 1. So we are considering the first test. To a small portion of sample C, I'm going to tell you how to measure the small portion. To a small portion of sample C, add 2 molar. 2 molar. This is how to write 2 molar. 2m. Molar is the same thing as mole per dm cube. Okay? 2 molar sodium hydrogen carbonate. Here is the formula for sodium hydrogen carbonate. In the exam, you are not expected to write it in words. You write the molecular formula. Sodium hydrogen carbonate, NaHCO3. Okay? To a small portion of sample C, add 2 molar sodium hydrogen carbonate solution. Then pass the evolved gas through lime water. Then pass the evolved gas through lime water. Okay, so right here we have, you are going to take small portion of sample C, add 2 molar sodium hydrogen carbonate solution, then you add lime water. Okay, so that the gas evolved will pass through lime water. That's what you've been asked to do. Is that taken? So I'm going to pick up my test tube. So where are we? So that I will know how to repeat what I've actually expressed. Where are we? Something is wrong with the microphone, so let me just use the free mouthpiece. Can you hear me now? So I need to shout. Can you hear me now? Can you hear me now? Okay. Now, I've taken another sample of C as well as the sodium hydrogen carbonate. This is the second time I'm taking that. So when I shake this, you tend to see, if at all you could not hear me, you saw the gas coming out. So the next thing you are expected to do is to take the lime water, okay? You pass the gas through lime water. So I can use, I'm going to slant the test tube like this. Then the gas evolves. You tend to see the milky solution at the slant area of the test tube. Okay, so how do we record our test? Right here. So I'm going to have the observation now. We have brisk effervescence of a colorless and odorless gas. Okay, brisk effervescence of a colorless and odorless gas. Now, this colorless and odorless gas is likely to be what? We cannot actually tell what the gas is until we test with what? The lime water. Okay? So I'm going to have, what happens to lime water? The lime water turned milky. So I'm going to have lime water turns what? Milky. Lime water turns milky. Okay? So I've been able to break the observation into two. We have brisk effervescence of a colorless and odorless gas. Lime water turns what? Milky. When you pass the gas through lime water, it turns what? Milky. Now, what will be the inference for this test? We are going to have gas is CO2. Okay? So it is only CO2 that tends to give that positive test, okay, where lime water turns milky. So since the gas has been confirmed, we can actually tell from what compound. So compound that exhibits a carboxylic functionality will give this positive test, okay, to lime water. Is that okay? So the CO2 was actually gotten from the carboxylic acid functionality. You could see that in COOH, we can see or get the CO2 out of it. Okay, CO2 is evolved. So in that process, we are going to write carboxylic acid confirmed. Okay, it's either you write carboxylic acid confirmed or you write COOH confirmed. Don't write both, oh. Either of the two, or COOH confirmed. Okay, we are going to take this for the inference. So mark will be awarded to identification of gas, which is what? CO2, and mark will be awarded for the mark will also be awarded for the correct confirmation, which is what? COOH confirmed. Okay, so I think I need to rewrite this. I need to rewrite this so that it will not exceed the space we have. Okay, we have gas is CO2, COOH confirmed. okay, or carboxylic acid confirmed. Makes sense? Can we proceed to the next test? If we can actually proceed to the next test, type in the chat test 2. Test 2. If we can proceed, if you can hear me, type test 2. Type test 2 if you can hear me. If you're having question on the first test, test 2, yes, test 2. Test 2. All right, let's consider the next test. Let's consider the next test. So we are going to take another test tube. We are going to take another test tube, okay? Here is the first test tube that we use for the test number 1, okay? Test for the COOH functionality. So I'm going to take another test tube right here. Can you see? Virtually all the test tubes that I'm using are actually very clean, okay? So make sure you rinse and clean up your test tube before you commence the qualitative analysis. Is that taken? So test number 2, the question right here. To another portion of sample C, the question now, test 2. To another portion of sample C, add 6 molar, this is how to write molar, 6M, same as mole per dm³, add 6 molar ethanoic acid. Add 6 molar ethanoic acid. Then add a few drops of H2SO4, tetraoxosulfate 6 acid. That is the right acid for this qualitative analysis. But in the reagent provided, H2SO4 was not actually stated for qualitative analysis. But your lab instructor can actually pick the H2SO4 that we use to acidify in quantitative analysis and make use of it in qualitative analysis. Are you getting me? The acid provided for qualitative analysis is hydrochloric acid. And if you make use of hydrochloric acid for this test, it is less effective, or it eventually slows down the esterification process. Is that okay? So the right acid to use for this test, which is test number 2, is H2SO4. So you can pick, your lab instructor can pick the H2SO4 from quantitative analysis and use it in qualitative analysis. So I'm going to be using H2SO4, okay? Since it is part of the reagent that we have for the, since it is actually part of the reagent that we have for the practical, okay? So I'll be using H2SO4. Then you need to make use of the heat source, okay? Probably you have Bunsen burner. We can actually make use of a gas cylinder, or any form of heat source can be used. But whenever you are warming, you need to make use of a water bath. But if water bath is not provided, you can actually, I will teach you how to warm such that it won't be a direct heating of the mixture. So avoid direct heating of the mixture, okay? So can we have our mixture? So we take sample C. Let's take sample C. Here is sample C. Small quantity. I've shown you the small quantity required. See the small quantity, okay? So we've taken the sample C. The next thing is to have 6 molar 6 molar ethanoic acid. 6 molar ethanoic acid. I have my 6 molar ethanoic acid right here. It has been prepared. So here is ethanoic acid. I'm going to add ethanoic acid right now. Okay, on adding ethanoic acid, we have no visible reaction yet. Okay, let's see whether there is a particular smell or odor coming out of it. So you tend to blow air into your nose. Okay, don't dip the test tube directly to your nose. Okay, now the next thing we are expected to do is to add H2SO4 to it. So we add H2SO4. So on adding the H2SO4, is that okay? We can now eat. Let's see whether we can perceive the odor coming out. Yes, I can perceive it slightly, but for it to be vigorous or to be observed easily, we need to eat the mixture right here. So the next thing is to eat the mixture. I hope you can hear me. We are about to eat the mixture. Yeah, someone is asking, when we see the question and we know the answer already, can we write the answer without performing the experiments? Now, it depends on the center where you are writing the exam. Some students, they've called me that the invigilator, or let me say the supervisor, insisted that they must conduct the experiments. Okay, so it depends on your exam center. You have to watch the situation around. Okay, so if the situation around actually accommodates you writing answers without carrying out some of these tests, then you can proceed. But I do advise, the essence of this live class is to teach you what you're expected to do. Okay, I've actually invested so much in preparing all these reagents, and in my last live class with you guys, I actually dropped my account number so that you can actually assist in the process. Okay, so my account number is in the live chat we had in the last exercise we did right here, so you can still support. Okay, and if you want me to drop the account number again here, I've invested so much in chemicals. I just believe that it is God that will reward me. So make sure you carry out the tests if the reagents are available. So I'm about to on the heat source. So here is the heat source. Can you see my heat source? So the next thing is to take the mixture that we are having right here. So this is how to heat. You ensure that you are having the blue flame, not the yellow flame. So don't do direct heating. Don't put the mixture inside the flame. So you just move it around the blue flame. Okay, you are to warm. You are not expected to boil. You are to warm the mixture. Okay, right here we are warming. Okay, I will continue to move the solution around. I'm not boiling, I'm warming. So you blow the air coming out of the test tube to your nose. I can perceive a pleasant fruity aroma. Of what? The pleasant fruity aroma coming from this mixture is indicating what formation, what has been formed. Which compound has that characteristic fruity aroma? Type in the comment section. So this is how to eat. Which compound has characteristic fruity aroma? Type in the comment section. Before we proceed, this is how to eat. You move it around. Okay, you have to warm, not to boil. All right. Can I off the heat source? I want to believe, assuming you are here, you should be able to perceive the sweet aroma. This is how to blow air to your nose. Okay, don't dip it into your nose. This is how to do it. So what compound has that characteristic fruity aroma or fruity smell? Type in the comment section. Drop that in the comment section. What compound or what class of organic compound has the fruity aroma? Yes. Bashir, we have esters. What is the class name for the esters? The class name for the esters. What is the class name for the esters? The process is esterification. What is the class name for the esters? What's the class name for the esters? What is the class name for the esters? The alkanoate. That's right. From so sorry for the pronunciation, I can't see it properly. Okay. Now we have ester has been formed, alkanoate. So what do we write here? We have a pleasant fruity aroma produced. A pleasant fruity aroma produced. Or you write a sweet fruity aroma. Anyone is allowed, okay? A pleasant fruity aroma is produced. Then in the observation, or sorry, in the inference, note that we were given sample C, okay? We introduce sample C into the test tube, followed by ethanoic acid. Now, the compound that reacts with the ethanoic acid is what we are testing for, not the ethanoic acid itself, okay? You know, in the mixture of sample C, we are having ethanoic acid and the ethanol. So we are still adding ethanoic acid. So we are not interested in ethanoic acid. We are interested in the other constituent, which is the ethanol. So it is ethanol that tends to react with ethanoic acid to give this fruity aroma, okay? So right here we are going to write alkanoate, okay, is formed. Okay, alkanoate is formed. Then what are we going to have? Since the sample C contains ethanol, that means we are testing for alcohol there. So we have OH confirmed. The hydroxyl functionality confirmed. Okay. Now I've seen students, some students actually sent their test results to me, and under inference they wrote ethanoic acid confirmed for this one. It is wrong, because you don't know if it is actually ethanoic acid. You don't know the number of carbon atoms in the chain, okay? So it is functional group that you are testing for, not the carbon skeleton. Now also, you cannot write ethanol confirmed here. You can only write OH confirmed, hydroxyl functional group confirmed, okay? So do not conclude that it is ethanol confirmed or ethanoic acid confirmed. So we can bracket it depending on what you intend to write. It is either alkanoate or ester formation. Okay, alkanoate or ester formation. So we've been able to confirm the OH group there. Is that okay? So these are the two possible tests based on the reagent provided. These are the two possible tests that we can have on sample C, which contains what? Ethanol and ethanoic acid. If this is clear, type COOH and OH confirmed. Type in the comment section COOH and OH confirmed. So we can move on to the next one. Type in the comment section COOH and OH confirmed. If you're having questions, you can drop it in the chat. Yes, we are testing for sample C. Yes, this is practical class for JUPEB chemistry practical. Yes, COOH and OH confirmed, that's right. So when you see this kind of test, don't conclude that it is ethanoic acid and do not write ethanol. You are not expected to write the IUPAC name of the compound. Yes, for those people that just joined, this class, after the live class, it will be recorded, okay? So you can still go through the video lesson. All right. Since it has been confirmed, COH has been confirmed, and the OH has been confirmed, then we can proceed to the next one. So we are done with sample C. Can you see that the exam you're going to write is actually very simple? But one thing about the exam is during the marking exercise, you need to follow the right procedure, okay? You need to follow the right procedure. You need to write the accurate observation and test. Now, one thing about this practical, during the marking exercise, if your test is wrong, okay, the orientation of your test, if it is wrong, if you've written sample C plus H2SO4, then you now have 6 molar ethanoic acid. That is wrong, okay? Once the orientation is wrong here, then the whole line right here for the observation and inference will be marked wrong, okay? So when test is wrong, observation and inference, even when it is correct, will be marked wrong. Take note of that. So make sure you take note of your test for this qualitative analysis. When you put the lime water before sodium hydrogen carbonate, you understand, and your observation and inference is correct, you understand, the final answer will be wrong because test is wrong, observation will be marked wrong, inference also will be marked wrong. Is that okay? So wrong test will lead to wrong observation and wrong inference. So when you have a wrong test, we mark you wrong for the observation, we mark you wrong for the inference, okay? Penalty noted. Type that in the chat. Penalty noted. Penalty noted. Penalty noted. For the marking exercise, penalty noted. Yes, Ascend, you are a regular student. Just follow up with the class. Now, for you are an A-level student, okay? You are not expected to write suspected under inference. Is that okay? It is not permitted. It is not allowed. Do not write something suspected, okay? Penalty noted, so that we can move on. Noted. Noted. All right, let's move on. We are now on the second part, which is sample D, mixture of copper 2 tetraoxosulfate 6 and sodium carbonate. So we are on the second part now, okay? So I'm going to dictate the structured question. So I would like you to write In an instance whereby you are with your writing material, you are expected to write, okay? Follow the order of the question given to you in the exam. This may not be the right order of arrangement of the question. Is that okay? Make sure you read the question before you write the observation and inference. Is that taken? And all the reagents, if provided, you can also conduct this practical so as to appreciate what you've been taught. Okay? So, D is a mixture of two inorganic salts. Mixture of two inorganic salts. That's copper 2 tetrasulfate 6 and sodium chloride. Mixture of two inorganic salts. Carry out the following test on sample D. Carry out the following test on sample D. Record your tests, observation, inference. The normal laboratory format for qualitative analysis are test, observation, inference. Okay? There is no other format that is acceptable. Test, observation, inference. Okay? Now, we are expected to, the first procedure right here, transfer 1.0 gram. Transfer 1.0 gram of D into a boiling tube. Okay? Transfer 1.0 gram of sample D into a boiling tube. Now, a student will ask me, now the next question that will come out of this is, a student will ask that, how are we going to measure the 1.0 gram of sample D? Okay, how will you determine the 1.0 gram of sample D? Now let me show you my spatula. Here is my spatula. We have two ends of the spatula. Okay, we have the flat end. Your spatula is just like your spoon. We have the flat end of the spatula. This is the flat end. And we have the curved end of the spatula. Here is the curved end. Okay, so I'm going to use the curved end to take the 1.0 gram. Is that okay? So the 1.0 gram, you are going to take the full portion of this curved end. That is a 1.0 gram. It is approximately 1.0 gram. Okay? That has been done before we started this practical. Type measurements confirmed. Now, while I was preparing for this exercise, this is my digital weighing balance. Okay? Here is my digital weighing balance. Okay? So I use the digital weighing balance to determine the approximated measurements using the spatula. Okay? So when you take the full portion of this curved part of your spatula, that is what we are going to introduce into the test tube. Can you see? This is our sample D, mixture of copper 2 tetrasulfate 6 and sodium chloride. Before mixing, I will show you what we were having before mixing. Before mixing, here is my copper sulfate before mixing. Is that okay? This is pure copper sulfate. And your common salts, your table salts, sodium chloride. See, here is sodium chloride. Can you see the white color? But after mixing, the blue color overwhelmed the white. So you are no longer seeing the white sodium chloride in the mixture. So now we are having this. Okay? So I assume this to be approximately 1.0 gram of the sample D. So I'm going to introduce this into my test tube. I will use this as the boiling tube. Can you see that? So gently into the boiling tube. Is that okay? So I have it in my test tube now. Then the next thing we are expected to do is to measure or add 5 ml of distilled water. You add 5 ml of distilled water to this 1.0 gram of the sample D. So this is my measuring cylinder. Okay, so I'm going to take 5 ml. Now 5 ml, I have my measurements. It has been calibrated. Currently the water is at 48. Okay, so I'm taking it down to 8 minus 5, that is 43. 43. Okay, here we go. Now the next thing is to shake properly. Okay, assuming we are having a bigger container, we are expected to stir it. Can you see that it is actually soluble in water? Okay, it has dissolved completely in water. Assuming it is an insoluble salt, we are going to make use of this. Okay, here is filter paper. Is that okay? But since the components of the copper-2 tetrasulfate 6 as well as the sodium chloride are soluble salts, it has actually dissolved completely. Is that okay? So this is what I'm going to use throughout the experiment for sample D. So here is the solution of sample D. Is that taken? So can we go through the test? We have to run through the test. Can we proceed with the test? If we can proceed with the test on sample D, write test, proceed. Test, proceed. If we can proceed with the test on sample D, just write test, proceed. Can we proceed? Yes, test, proceed. Bashir, test, proceed. Caleb, test, proceed. We need more responses. Test, proceed. We have to be fast. We are losing our light source already. I hope we can still see the board clearly. All right, let's proceed with the test. Okay, so I'm going to read the question for test number 1. Test number 1 on sample D. Now, since we've been able to form the solution right here, no test has been carried out on the mixture. We only carry out what? The solution. The solution has been done here, so there is no inference for the solution. We've only dissolved the mixture of copper-2 tetraoxosulfate 6 and sodium chloride in water. Okay, so there is no inference for this. We've only observed that it comprises of what? Soluble salts. Is that okay? Now, test number 1 on this. After forming the solution, to a small portion of solution in Roman figure 1, okay, so the small portion of solution that was formed, add aqueous sodium hydroxide in drops and then in excess. We have to add aqueous sodium hydroxide. Please always ensure that you write the state of the compound that you are using for the test. We have sodium hydroxide, AQ, right? It implies what? Aqueous. That means the solution of sodium hydroxide. Not that you dropped sodium hydroxide pellets into the mixture. Now, we have to add in drops. So we are going to make use of our dropper in order to add in drops and in excess. Okay? So we are going to make use of the dropper to add in drop and in excess. So let me rinse my dropper. So here is the dropper that I'm going to be using for this test. So I have to rinse the dropper. It's kind of dirty. So I've rinsed my dropper, okay? I can still see certain particles trapped in it, but let us proceed. This rubber dropper will be provided in your exam. See, this one will be provided, but the upper part has broken, so it is opened. I can't make use of it. It cannot pick up the solution needed, okay? So you check the dropper you are using. So I will use this one, okay? I'm using this dropper. So the first thing we are expected to do is to take the sodium hydroxide, right? We take the sodium hydroxide. Here is sodium hydroxide. I'm going to add in drop and then in excess. Wow. Now look at this. Right in the dropper, we are having a pink color already, which shows that the constituent of this dropper is what? Is it an acid or a base? You have the dropper having a colored or pink coloration. Is it an acid or a base that is in it? When you have sodium hydroxide with this, so sodium hydroxide has actually interacted with what? With what? I think there is phenolphthalein in this solution. There is phenolphthalein in this, okay? So in my dropper, I've actually observed that it was used for phenolphthalein. So the pink color that was formed there was actually as a result of the contact of phenolphthalein with a base. Is that okay? So I'm not going to use that again. So what do? Our dropper is not actually functioning, but there is a way I can actually go about it. Where is my sodium hydroxide? Sodium hydroxide, all right. So I'm going to slant the dropper like this, okay? Can you see? I have a badge dropper here, but I'm going to still make use of it. Where is our first portion? So let's take the first portion. Just take little quantity, can you see? Take little quantity inside another test tube. This is an empty test tube, okay? So this is enough. Then the next thing is to add the sodium hydroxide in drop. So I want to take with the badge test tube, with the badge dropper again. And you see I will slant it. Now in drop. What can we observe? Can you see the color has actually changed slightly? Which one is lighter? This one is lighter compared to what we're having initially. So we have a light color, okay? Light blue color right here. So we have a light blue precipitate right here, okay? It is cloudy slightly. That's why I'm actually calling it a precipitate. So it is light blue that we are having right here. So what will I do? Light blue, what ion is being tested for right here? Sodium hydroxide added. We have a light blue. Then, can we add in excess? Okay. Light blue precipitate. I'm going to add in excess now. I can see tiny particles there, okay, which shows that it is insoluble in excess what? Sodium hydroxide. Okay, I can see tiny particles, okay, which shows that it is not a clear solution. So it is insoluble in excess what? Sodium hydroxide. So what do we write? We have, for the first test, we have light blue precipitates. Do not write PPT. You write precipitate in full, precipitates. Okay? Forms. It's either you write forms or is formed. Is that okay? Now, what happened when it was added in excess? Insoluble. It was insoluble. Insoluble in excess what? Sodium hydroxide. So we have light blue precipitate forms insoluble in excess sodium hydroxide. Now this particular test will have what inference? Cu² plus presence. Cu² plus presence, okay? Copper 2 plus presence. If you are okay with this inference, type copper 2 plus presence. If you are okay with the explanation, type copper 2 plus presence. Type copper 2 plus presence. Now, at the end of this qualitative analysis, you will be asked to write the equation for each reaction. So at the end, we are going to write equation for each reaction. Copper 2 plus presence, yes. Cu² plus presence. All right, let us proceed to the next one. Now let's take the next question. To another portion, you can write that, to another portion of the solution. So another small portion of the solution. Add aqueous ammonia, dropwise and then in excess. Add aqueous ammonia dropwise and then in excess. Are we there? All right, let's take the small portion. So we are going to take small portion from the solution of the sample D. Okay, here is the small portion. Now note this for your exam. Note this. Let me keep this. Now you need to note this for your exam. Under the test, there are two ways to represent the test right here. You can write sample D, D plus water plus sodium hydroxide in drops in excess. Or you write D solution, it is allowed. Since water has been used to dissolve the mixture of the sample D, okay? You can write D solution or D plus water. Is that okay? So those are the two ways by which you can express the test. Now we are on the next one. D plus water, that's the solution that we are having right here, plus ammonia in drops and in excess. So we are going to add ammonia in drop. So let me rinse my, you are expected to rinse the dropper anytime you are taking another fresh reagent. All right, I've rinsed the dropper. So I'm going to take the ammonia in drop, aqueous ammonia in drop. This is my ammonia right here. You can actually perceive the smell anytime you are conducting the qualitative analysis. It has characteristic what? Urine smell. So it is actually smelling like what? Urine. Okay? So I'm going to take in drop. If your dropper is not in good condition, you slant the dropper. Okay? So I'm also using a dropper that is not in good condition. So you slant the dropper. Is that okay? So we are going to add in drop. In drop. Alright, I've added in drop. What can we observe? We are having a light blue precipitate. Okay? So by the time I add in excess, the color tends to change. So let me add in excess ammonia. Can you see in drop? We're having a light blue precipitate. So let me add in excess. In excess now. Here's my ammonia. Let's add in excess. Excess. There is no quantity for excess. So I've added the ammonia in excess. Okay? Now, this is not giving me the desirable results. Okay? Because we are expected to have a deep blue solution. Okay? On adding in excess. So, let us continue. So, we have light blue precipitate which dissolve in excess ammonia. Light blue precipitates. Write precipitates in full. Precipitates. Okay? Don't write PPT. If you write PPT, we mark you wrong. Okay? Light blue precipitates which dissolves in excess aqueous ammonia, NH3 aqueous. Okay? To form deep blue solution. To form deep blue solution. All right. So when the ammonia was added in drops, we got what? A light blue precipitate. So when ammonia was added in excess, you are expected to see the precipitate dissolves in excess what? Aqueous ammonia to form a deep blue solution. Precipitate is actually different from solution. Precipitate will have a cloudy what? Solution. A cloudy solution is precipitate. That is, you tend to see tiny particles forming a cloud. Then when it forms a solution, it will be a clear mixture, or let me say a clear solution. Is that okay? So learn to differentiate between precipitate and solution. So we have light blue precipitate which dissolves in excess aqueous ammonia to form what? Deep blue solution. Now, what is our inference? The inference for this exercise is deep blue solution is what? We have Cu, NH3, we have 4, then it is a complex right here. Okay? We have a triamine copper 2 complex. Now, the complex right here is Cu, NH3, 2 plus. Now, also on this side, when you reacted the Cu2 plus with sodium hydroxide, it will give you the light blue precipitate that we are having here is, you can write it before the Cu2 plus present. So let me have it before Cu2 plus present. So you can write precipitates of what? CuOH2
2. That's copper 2 hydroxide. So that's when you now say Cu2 plus present. Okay? So you have to indicate the precipitate, the compound that formed the precipitate, then before you write your confirmation there. So right here, this is confirmatory test for the Cu2 plus. So I'm going to have Cu2 plus confirmed. Okay, the ammonia is used to confirm the Cu2 plus there. Copper 2 plus confirmed. So we are going to have deep blue solution of what? Of Cu NH3 close bracket 4. Then in complex form, it is a complex ion 2 plus. I hope you can see the lower part of the board. If you can see it clearly, type clear. If you can see it clearly, type clear. If you can see it clearly, type clear. Yes, if you can see it clearly, type clear. Now make sure you look at the complex formed, that deep blue solution. Make sure you take note of the formula representation. Take note of the formula representation for the Cu NH3 bracket 4 close brackets 2 plus. Take note of the complex ion there. We are still going to write the chemical equation because in your exam, it will always end, the question will always end with write chemical equation for the test. Okay, we are still going to consider the chemical equation for some of the tests that we have there. So for the first one, with sodium hydroxide, the precipitate is copper 2 hydroxide. While for the second one, the deep blue solution is the tetraamine copper 2 ion. Okay, that's Cu NH3 for 2 plus. If that part is clear, type clear. If it is clear, type clear. So we use that to confirm Cu2 plus. We use that to confirm Cu2 plus. So we'll move to the next one. We move to the next test. Can we consider the next test? Test number 3 for sample D. Test number 3 for sample D. To a fresh portion of sample D. To a fresh portion of sample D in a test tube, add a few drops of potassium hexacyanoferrate 2. Potassium, note this in your exam, they may write the compound in words, okay? But when you are writing the test, you are not expected to write in words, you are expected to write the chemical formula. So potassium hexacyanoferrate 2. Is that taken? Now, the potassium hexacyanoferrate 2, I'm going to write the formula. Is that okay? But the issue we are having right here is that when I requested for potassium hexacyanoferrate 2, the lab vendor provided hexacyanoferrate 3. Is that okay? So you are likely to face similar thing in your exam. So for this particular test, we are going to write the expected observation. So this is the potassium hexacyanoferrate 2, okay? So I'm just going to demonstrate so that you see what is happening there. Potassium hexacyanoferrate 2. So I'm going to take another test tube, okay? So let's take another test tube, but before we carry out the test, can I write the test for this next analysis? So let's write the test. So I have to clean this. So that's question number 5. Question number 5. We are having 5. Sample D solution or plus water plus the potassium hexacyanoferrate 2 has the formula K4 FeCN6. Okay, this is how to write the chemical formula for the compound. Is that okay? So what observation? Can we carry out the observation now? So I'm having, you take the sample again. Here's another test tube. Okay, if you don't have excess test tube, or you don't have required number of test tube for this test, are you getting it? Always rinse your test tube. You can even make use of 2 test tubes throughout the whole qualitative analysis. But me, I'm having like 12 test tube right here, so I can use any of the empty test tube. So can I take the small sample? Here is the sample D, okay, plus water. Sample D plus water. So I'm going to introduce the potassium hexacyanoferrate 2. So here is my potassium hexacyanoferrate 2. I've told you the condition of this reagent right here. So we have this. So just introduce, okay. Now, you know we are having mixture of inorganic salts. The reason why we are not seeing the required change, assuming the test is conducted on copper 2 sulfate directly, there will be no masking of the copper by sodium. So copper has been masked by sodium, okay? That's why I'm not saying this, but the desired observation is what we are going to write now. We expect to see a reddish brown precipitate formed. Is that okay? So reddish brown precipitate. We have reddish brown precipitate formed. Where is my marker? We have reddish brown. In some cases, you can have chocolate precipitate, but chocolate, we don't really take chocolate as a color. Is that taken? So reddish brown precipitates formed. Okay, so we have a reddish brown precipitate. Now, this particular test is also confirming the copper. Is that okay? But before you write the confirmation, what is the formula for the precipitate formed? Okay, what is the formula for the precipitate formed? Now, the precipitate formed, you know that potassium is found in group 1 in the periodic table. Potassium is found in group 1, and the oxidation state of the copper is +2. Okay, so if you are having group 1 elements with subscript 4, the copper that is replacing it is having oxidation state of +2. So 4 divided by 2, that is what? 2. So it will be Cu2 in place of what? K4. So make sure you master this. So we are going to have precipitates of, we have Cu2. Is that okay? Cu2. Then you copy what we are having here. We have FeCN what? 6. Okay? So that is the precipitate formed. Is that okay? Then you have Cu2 plus confirmed. This is a confirmatory test also. Confirmed. Is that okay? So write Cu2 plus confirmed if this is clear. The test is solution D. This solution plus the potassium hexacyanoferrate 2. Okay? So the observation is what? The expected observation is reddish brown precipitate formed. Then the precipitates will be identified. The compound formed will be identified. That's Cu2, then hexacyanoferrate what? Ferrate 2. Okay. Now we are going to have the Cu2 plus confirmed. So if you are clear with this, write Cu2 plus confirmed. Cu2 plus confirmed. Cu2 plus confirmed. Cu2 plus confirmed. If this is clear, type Cu2 plus confirmed. If this is clear, type Cu2 plus confirmed. Cu2 plus confirmed. That's good. Cu2 plus confirmed. Cu2 plus confirmed. All right. So we can proceed with the next one. Let's proceed with the next one. Now write the question. The next test, that's Roman figure, okay, number 6. So another portion of solution in Roman figure 1 when we formed the solution. Okay, this is the portion we are talking about. So another portion of solution, okay, had silver nitrate solution. But now I'm going to correct something about this. Add silver nitrates. Okay, the reason why we are adding silver nitrates at first, in this test we are testing for chloride ion. We are on this now. We want to test for the chloride ion, but the standard test is that you are expected to add HNO3, that's nitric acid. You are expected to add nitric acid to the fresh portion right here before you acidify the solution. You acidify by adding nitric acid to this. Then you now add the silver nitrate. Then you observe a white precipitate. Is that okay? But in the reagents provided, or the reagents that was actually stated from the exam body, is that okay? HNO3 was not stated. So the HNO3 was not stated, and we are expected to have HNO3. So if we are to replace it with another acid, if we attempt to use hydrochloric acid, this one, if we attempt to use hydrochloric acid, it will add on to the concentration of chloride in the solution, because we are actually having sodium chloride here before. So we are now still adding another compound that contains chloride. We are going to see a white precipitate, but that is not a standard test. Is that okay? So something is missing, but if the lab instructor eventually provide the HNO3, you are expected to add the nitric acid to this. Okay? So let us use the ideal test. Then we now use the other way around. The ideal test is that you add HNO3 to the fresh portion of solution D. Then after adding HNO3, you now add silver nitrate. Is that okay? Let's try and use HCl in place of HNO3, because in the exam, in the guide, in the practical guide, we were provided with HCl. So let's try and use HCl. Let's see what we have. This is my HCl. I told you the concentration of the chloride will increase in the process. But this is the only portion that we've been sharing. So I need to transfer little amounts into another empty test tube. Okay? So we are having this. So this is the fresh portion that we are talking about. Let me add HCl. Let's acidify it with HCl. We are expected to use HNO3, but not provided. Let's add HCl. So we've acidified it. Can you see that the color changed slightly? Okay, we have a slight color change. I see there is traces of brown around the blue color or let me say it is looking like green, okay, that means it has been acidified. Then after acidifying the sample D solution, okay, the solution of sample D, after acidifying, the next thing is to add the silver nitrate. Where is our silver nitrate? Silver nitrate. Yes. Now, the silver nitrate is always dark or black solution. Can you see? You make sure you mix before you add it, okay? So we had the silver nitrate in drops. Let's take our dropper. We make use of the dropper in drop. Let's add in drop. So I've slanted the dropper so I can add in drop. On adding in drop, can you see I've started observing a white cloudy what? Precipitate. Is that okay? White cloudy. Can you see? We have a white cloudy precipitate is formed. Can you see? So when you shake properly, normally assuming we use the HNO3, I'm expected to see a perfect white cloudy precipitate. Is that okay? So if the examiner provides the HNO3 in your exam, that's the nitric acid, you are expected to use nitric acid. Right here, I'm using HCl. That's what has been stated for this practical. So the next thing, after we've added the AgNO3, which is the silver nitrate, we observe a precipitate. This is the white precipitate. Can you see particles there? So let us write the test. Let's write the test. We have, I hope you can hear me. Please confirm if you can hear me. I hope you can hear me. I hope you can hear me. Hope you can hear me. And I believe I've been able to distinguish the acid used perfectly to you. You are expected to use HNO3, but in the practical guide sent to us, it is hydrochloric acid that we are having. And the hydrochloric acid is not suitable for this test because the chloride ion is already present in the mixture. Chloride ion is present in the mixture. Note that chloride ion is present in the mixture already. The mixture that we are having here, chloride ion is present, and we are still adding HCl, which is hydrochloric acid. So the concentration of the chloride tends to increase. Are you getting it? So the suitable acid for this particular test is nitric acid. So when we add nitric acid, we do not have common ion. Is that okay? So, but in the case of the HCl, the hydrochloric acid, we are having common ion, which implies that the concentration of chloride has been what? Increased. Is that okay? So, take note of that. Can we write the test? Can we record our test? What have we done? Can we record our test? Yes, let's have the test. I'm going to state the correct test using HNO3. So if you are provided with HNO3 in your exam, use HNO3. But if you are being served with hydrochloric acid following the procedure, or let me say the reagent that was stated for this exercise, make sure you write the HCl, but it is not ideal. So let us have the sixth one. We are having D plus H2O, that's the D solution, okay, plus what? What did we add at first? We added the acid to acidify the sample D. You had HNO3, okay? So on adding HNO3, it has been acidified. You will now add silver nitrate, AgNO3. Is that okay? You have silver nitrate. What is our observation? We have a white precipitate formed, right? We have a white precipitate formed. Let me clean this. we have white precipitate formed. So we are on white precipitate formed. White precipitates. Do not write PPT. Precipitates. Forms. Okay. It's either you write white precipitate forms or white precipitate is formed. So any of this is correct. Okay. So after which the white precipitate has been formed, can we now add? Yes, we can now add ammonia to the precipitate. Okay. What is the precipitate formed? What is the precipitate formed? Let's look at this very well. We have AgNO3 right here. It's been added to sample D. The chloride in it will substitute the nitrates in silver nitrate. The NO3 will be substituted by Cl, that's chlorine. So when NO3 is substituted by Cl, okay, what compound is formed? Type that in the chart. So when NO3 is substituted by a chloride ion in silver, what compound is formed? Type that in the chart. To confirm you are hearing me, type that in the chat. In silver nitrates, the nitrate NO3 is being substituted by chloride ion. What compound is formed? So it is the compound formed that gave that white precipitate. It is the compound formed that gave that white precipitate. Now I will always like to have, let me add something to the precipitate. Since it is cloudy, we observe a cloudy or a cloudy precipitate. Let me write cloudy. Let me use a common English. White cloudy precipitates. Okay, forms. So what is that white cloudy precipitate? I've told you the compound formed. The silver bond with the chloride. That is, the chloride replaced the nitrates in this compound, in silver nitrate. What compound is formed? Type that in the chat. What compound is formed? Yes, we have AgCl, that's correct. Silver chloride, that's correct. Silver chloride. Silver chloride, that's correct. Yes, silver chloride. Let's proceed. So do we have inference for this? Do we have inference for this test? Yes. We have precipitates. Precipitates of silver chloride, AgCl. Is that okay? Now, we cannot write what we do not see in the inference, okay? I could see silver from silver nitrate, and I could see chloride due to the what? The observation that we got from here, the white cloudy precipitates. Is that okay? Now, the last part for this test on sample D, can we write it? The last part for the test on sample D. This particular one is so another portion of solution. Okay, add the one we just concluded. Add HNO3, then what? Silver nitrate in drops. Okay, then silver nitrate in drop. Then the last test. Add aqueous ammonia to the precipitate obtained in test 6. Okay, add aqueous ammonia to the precipitate obtained in test 6. Add aqueous ammonia to the precipitate obtained in test 6. Are we there? Add aqueous ammonia to the precipitate obtained in test 6. So let's add aqueous ammonia and let us see what we have. And you see the color is changing over time. Okay? It was because we added HCl, that's why we are seeing traces of the green. So you expect to see a white precipitate. Now, where is ammonia? Ammonia is to be added. Ammonia, here's our ammonia, okay? So we add ammonia to this precipitate. So when ammonia is added, what happens when ammonia is added? Now you see that the particles tend to dissolve, okay? We have precipitate dissolves, okay? Precipitate dissolves. So number 7, let me write number 7 with black ink. So 7, precipitates is what we are considering, okay? So precipitates AgCl, okay, plus ammonia. Is that okay? It has been confirmed that the precipitate is AgCl, so we can write it like that. Or you write precipitate in 6 plus, okay? So this one is only showing that chloride is present. Chloride present. Cl minus present. Is that okay? So we are on addition of ammonia to the precipitates. So the white precipitates dissolves. White precipitate dissolves. Is that okay? So what has actually happened? We've gotten a formation, there is a complex formed that led to this observation. What complex is that? The silver right here will bond with ammonia. Is that okay? You know that silver has valency of 1 in this case because of the univalent nature of the silver. That is why silver chloride is formed, AgCl. So it is univalent. Now, the ammonia also will bond the same way with the silver. Is that okay? Notably, when ammonia is bonding with silver, we are expected to have AgNH3 as well. But the complex formed precipitates of, we are having AgNH3 close bracket 2. Then we have what? 2 plus. Okay? So precipitate of this is formed. AgNH3 2. Then the complex ion is what? 2 plus. Is that okay? Now this particular observation reflects the confirmatory test for what? The chloride. Because if chloride is not present, when we added ammonia to the precipitate formed, the white precipitate will not dissolve. Okay? So since the white precipitate dissolved, it has actually confirmed for what? The presence of what? Ammonia, the presence of chloride. So we can now write chloride present. But the previous inference is chloride present. Now with the ammonia, we can write chloride confirmed. Okay? We can now write chloride confirmed. So let's write chloride what? Confirmed. I've been able to distinguish the previous test with blue and what? Black. So chloride Cl minus confirmed. Okay, Cl minus confirmed. So anytime you're writing the inference, the standard format is write the compound of what? The precipitate formed before you write your ion present or confirmed. So right here, the precipitate is this AgNH3 2 close bracket, what, 2 plus. Then chloride what, confirmed. If this is clear, type clear. Cl minus confirmed. Type Cl minus confirmed in the chart. Type Cl minus confirmed in the chart. Then, since we've been able to conduct all the possible tests, the next thing we are expected to do is to write the possible reaction for test number 1 to 7. We write the chemical reaction for test number 1 to 7. So your question will always end with write chemical equation for the test in this qualitative analysis. Now, before we go into the chemical equation, let us go through the mixture again. In the first mixture, that is sample C, we have 2 compounds, the ethanoic acid and ethanol. Those are the constituent organic compounds that we have in the mixture. Okay, please type chloride confirm to confirm if you're actually hearing me before I proceed. Okay. Type chloride Cl minus confirmed. All right, Cl minus confirmed. Cl minus confirmed. Before we now go into the chemical reactions. Yes, Cl minus confirmed. So we can add to this, white precipitate dissolves into clear solution. Okay, white precipitate dissolves easily into clear solution. Since we've written white precipitate dissolved easily into clear solution. Okay, so we can proceed. Please permit me to adjust this. Write soluble complex. Soluble, since it has actually formed a clear solution. Write soluble complex ion of, please kindly adjust this. Write soluble complex ion of, then this. Is that taken? Change that to soluble complex ion of AgNH3 close brackets 2 plus. Okay, since it has actually given us a clear solution, we expect to have soluble complex ion. Okay, soluble complex ion. It is no longer a precipitate since it is a clear solution. Soluble complex ion. So if you've actually captured this, type soluble complex ion in the chart. Soluble complex ion in the chart. Then we go to the chemical reaction. Then we end our qualitative analysis class. Okay, I'll give you time to go over the quantitative analysis. The video is on my channel. Okay, so I've actually tagged the video to this qualitative analysis as well. You are expected to go through the quantitative analysis. Then, if you'll be interested in 11 type soluble complex ion. All right, soluble complex ion. Soluble complex ion. All right, that is clear. So let us run through the equations, okay? Let us run through the equations. Let us run through the equations. Now, here is the question. The final part of the qualitative analysis. Here is the question. Are you with me? Are you with me? Can we take the final part of the question on qualitative analysis? You'll be asked to write the chemical equations. Now let's take the question. Write an equation. Write an equation for the reaction taking place. Write an equation for the reaction taking place in 2A above. Okay, the 2A is our first test on sample C. In 2A above, that's the first question. Write an equation. So if it is an equation, that's singular. That is, you are going to write one out of the two. Write an equation for the reaction taking place in 2A above. Okay, that's singular. Write an equation, just one. Then the next question, provide an equation. Provide an equation where the key is. So the next question, provide an equation for the reaction occurring in 2B above. Okay, that's for the sample D. Provide an equation for the reaction occurring in 2B above. Are we good to go? If you've gotten the question, type question taken. Question taken. Type question taken. If you have the question, type question taken. Right, type question taken. Yes, Emisioluwa, that's right. Promise, you're welcome. Question taken. Don't just watch my video lessons. Make sure you like the video so that it can actually get to a wider audience. Like my videos. Make sure you share the quantitative analysis with your friends. Make sure you subscribe to this channel, okay? Make sure you subscribe to this channel. This particular channel is Organotope Chem Clinic. Subscribe to Organotope Chem Clinic. And if we'll be having the biology practical, it will be on my second channel. So make sure you subscribe to the second channel, Organotope Science Academy. I'm going to write that on the board. The second channel is Organotope Science Academy. Okay, Academy. Okay, Organotope Science Academy. So this is the second channel. This is where biology practical will be taken. Okay, biology practical will be taken on Organotope Science Academy, not Chem Clinic. Is that okay? So make sure you subscribe to this channel. Is that okay? Organotope Science Academy. And also, if you want to support these live classes, don't just say probably you are done with your exam. Okay, we've actually invested so much on data. We've actually invested so much on the chemicals that we are using. you can actually support with anything. Is that okay? So once you are done supporting us with something, any transfer made will be appreciated. So support us. I'm going to tag the accounts details to this particular chart. Is that okay? Make sure you support us with something, then we can actually do more for you guys or for every other student. Is that okay? So make sure you support us. We've actually used so much on reagents. Support us, support Organotope Chem Clinic. Okay? No amount is actually small for this exercise. If you are ready to support this channel, indicate ready to support. Indicate ready to support in the chat. Ready to support. Type ready to support. Now it is time to support. Students are no longer stating anything. No one to support. All right, let's proceed. All right, let us proceed with the reactions. Let us proceed with the reactions. Let's proceed with the reactions. For the first part, which is the test for the carboxylic acid functionality, do we still remember the test we carried out for carboxylic acid functionality? Carboxylic acid functionality. Sorry, just give me a few minutes. All right, on carboxylic acid functionality. Let's take that. Yes, if you can hear me, type proceed to reaction. Yes, Aisha, we appreciate that. Ready to support. Can we proceed to reaction? Can we proceed to reaction? Type proceed to reaction. Type proceed to reaction. All right, proceed to reaction. Sorry, I'm trying to connect the charts with my laptop device here. All right, let's take the first reaction. We have sample C plus 2 molar sodium hydrogen carbonate with what? Lime water. Okay, so we have two-step processes there. The first one is the reaction with sodium hydrogen carbonate, and the second one is the gas evolved reacted with lime water. What is the molecular formula for lime water? Type that in the chat. Molecular formula for lime water. Molecular formula for lime water. Type that in the chat. Lime water. What's the molecular formula for lime water? What is the molecular formula for lime water? What is the molecular formula for lime water? We should not just conclude on the reaction. We need to understand what we are doing here. What is the molecular formula for lime water? Yes, I need your responses, please. Yes, calcium hydroxide from Dave. From Dave. If you are just joining, just follow up with what we are doing now. Then after the live class, it will be saved for you to rewatch, okay? Just follow up with what we are doing now. After the live class, it is going to be saved. Yes, we need more responses on that. Yes, Emisioluwa, that's correct. Calcium hydroxide. So let's write the equations for this. So if we are considering the first test, we have the compound tested for is what? The carboxylic acid functionality. Is that okay? So we are going to have this. Now, assuming we want to conclude on the compound, you know, we do not know the number of carbon atom, okay, that is actually linked to the carboxylic acid functionality. So we can actually generalize the alkyl group connected to the carboxylic acid functionality, okay? Alkyl group is denoted as R. Is that taken? Now we have the carboxylic acid functionality. That's RCOOH. Then we reacted it with what? Sodium hydrogen carbonate. Sodium hydrogen carbonate. Then what is the product formed? When we reacted this with sodium hydrogen carbonate, we have RCOONA. Okay? This is sodium alkanoate. Sodium alkanoate is formed, okay? Then what do we have that's accompanying this particular reaction? We have formation of water. Then a gas is evolved, which is colorless and odorless, and we said the gas turned lime water milky. That is CO2, okay, evolved. So when you want to express effervescence, you point the arrow upward. That means the gas is evolved. Can we check if the equation is balanced? We have 2 carbon atoms right here. We have 2 carbon atoms right here. Oxygen, 2 here, plus 3. That is what? 5 oxygen atoms. We have 2 plus 1 plus 2. That is 5 oxygen atoms. Then the sodium here is 1 atom of sodium. 1 atom of sodium. Then we have hydrogen, 1, 2. 2 atoms of hydrogen. Then from the water molecule here, we have 2 atoms of hydrogen. Makes sense? So the gas evolved here was passed through what? Lime water. Is that taken? So the complete equation right here is CO2 plus the calcium hydroxide, which you've stated as what? Lime water. We have CaOH what? 2. Okay? Now this results in what? The calcium hydroxide here tends to form carbonate, CaCO3. Are you getting it? So it is a precipitate. Precipitate. Okay, that is the milky solution that we're having. That's the milky solution that we saw in the reaction. Then this reaction is accompanied by what? Can you state that in the chart? Plus what? State that in the chart. Plus what? For you to have a balanced equation, calcium carbonate was formed plus what? Okay, now that save time, we have what? H2O. Okay, let's check if the equation is balanced. 1 carbon atom, 1 carbon atom. Calcium is 1 atom here, calcium is 1 atom. Oxygen is 2 atoms here plus 2, 4. We have 3 atoms of oxygen plus 1. That is what? 4 atoms of oxygen. Then what do we have left? Hydrogen. We have 2 atoms of hydrogen here. We also have 2 atoms of hydrogen here. Make sense? So we've been able to write the chemical equation. So if you are considering the first test, you are expected to write this complete equation to score your what? Full mark. Okay? To score this right, you have to write the complete equations. Make sense? If we can proceed to the test 2, type reaction for test 2. If we can proceed to test 2, or you are having question on this, state the question in the chat. I chat reaction for test 2. Yes, indicate in the chat. Can we proceed to the reaction for test 2? Can we proceed to reaction for test 2? Can we proceed to reaction for test 2? State in the chat. When you are done watching this video lesson, make sure you subscribe to Organotope Science Academy. Can we proceed? Yes, promise reaction for test 2. The test 2 is esterification reaction. All right, I've actually tagged the account details to the chart. Okay, for those of you that you want to support the process, we've invested so much in this practical. Okay, and after this live class on qualitative analysis, make sure you go through the quantitative analysis, then structure your questions, then we can actually meet again before 11. Though I can structure the class for 11 o'clock. Okay, so for those of you that you'll be live by then, make sure you join the question and answer class on quantitative analysis. Then by then you would have digested everything on qualitative. If there are questions, you are free to join the live class. Okay, it is not a premium class, it is not a paid class, it is free for all. But if you want to support, you can use the account details. I've pinned the account details to the chat so everybody can see it. The name is Adeniji Temitope Pampe. All right, let's proceed with the reaction. I hope you can see the board clearly. Let's proceed with the reaction. Test 2. Reaction for test 2. For those of you that you're just joining, here is reaction for test 1. You'll be asked to pick a reaction, okay? That's reaction for test 1. Reaction for test 2. Test 2. We all know that test 2 is esterification process, esterification. And what did we do? In test 2, we added 6 molar, sorry. In test 2, we added 6 molar ethanoic acid, okay? And after adding 6 molar ethanoic acid, we used acid catalyst, okay? And I stated that the suitable acid catalyst is the H2SO4, right? Okay, so we acidified the process and we got what? Ethanoate as the product. Is that okay? Then the ethanoate formed has a pleasant fruity smell. Okay? Pleasant what? Fruity what? Smell of ethanoate or ethanoate. So can we write the equation? We do not know whether it is ethanol that we are testing for. The only thing we know is that we are testing for what? The alcohol or alkanol functionality. So do not fall victim by stating that it is ethanol. That shows that something has been revealed to you. They tend to mark you wrong. If you are stating a specific compound, you will be marked wrong. Okay? So we are having ethanoic acid was added to the sample C. We have alcohol. And I write that as ROH. Okay. We have ROH plus the 6 molar ethanoic acid, but we are using archanoic acid, RCOOH. Okay? Note that the reaction is a reversible process. You have to indicate that. So the forward reaction is catalyzed by what? A mineral acid. The forward reaction is catalyzed by a what? Mineral acid. Is that okay? You know, we added acid as catalyst. So let us check how is the alkanoid formed. From here, we have acid, we always release hydrogen ion. Then this will serve like a base, it will release the hydroxide. Is that okay? So OH with hydrogen there will form water. Then when hydrogen leaves this alkanoic functionality, it will leave what? A negative ion here. And this one will leave a what? A carbonium ion here. Carbonium ion will bond with the anion right here. Then we have our ester formed. Is that okay? What is the ester formed? We have RCOOR prime. Okay, I've indicated prime here. It can be any length of the alkyl group. Okay, so I've indicated prime. Plus what? We have water. Is that okay? Here is the ester formed, or the alkanoids. Here is the ester, which gave us what? The sweet, fruity what? Smell or aroma. The sweet, fruity aroma that was formed is actually the sweet, fruity aroma is indicating that it is what? Alkanoids or ester. Is that okay? So this is the chemical equation for test number 2. Test 2 clear. Type that in the chat. Test 2, reaction for test 2 clear. Type that in the chat. Reaction for test 2 clear. Type that in the chat. Type in the chat if the reaction for test 2 is clear. Type in the chat. If the reaction for test 2 is clear, type in the chat. Yes, promise reaction for test 2 clear. We are losing our light source already. Should I on generator for you to complete this class? And you see that you have to support in all ramifications. Do we need to on generator to complete our classes? I'm losing all the lights available here. Can you still see the board like this? All right, since the test 2 reaction is clear, then we can proceed. Test 2 reaction clear. That means we are done with sample C, the reaction for sample C. You'll be asked to write an equation. An equation implies just one out of the 2. Is that okay? Okay, the board is still clear. Thank you, promise. The board is still clear. So let us proceed to the next one, which is sample D. Sample D. Sample D. All right, for sample D, what do we have there? What test did we carry out? The first test on sample D. We're having the solution D, this solution with sodium hydroxide. Okay, this solution with sodium hydroxide. So the D solution with sodium hydroxide, we are testing for copper there. Copper. So test 3, or let me just make it equations for sample D tests. Okay, equation for sample D tests. All right, the first. All right, can we proceed? We've been having issue with network here. Is the reaction for test 3 clear? Sorry, I have to reconnect the live class. Is the reaction for test 3 clear? Is reaction for test 3 clear? Can you hear me? Is the reaction for test 3 clear? Is on the board. Indicate in the chat if the reaction for test 3 is clear. Indicate in the chat, is the reaction for test 3 clear? Are you with me? Is the reaction for test 3 clear? Yes. From promise, reaction for test 3 clear. Okay, since we have confirmations on reaction for test 3, let's take the next one.